This is the video lecture on division mental strategies. We're going to, as we've done in each of the other operations, look at some mental strategies for division in this video lecture, and then we will see how these get extended to more formal algorithms in the next one. So, there are four common mental strategies for division that involve single-digit divisors that we will explore and examine. We're going to look at each strategy and how it might be used by children when doing mental math, and then of course I'll give you an opportunity to try each of these on your own. We'll end this, as we've ended all the other mental strategies, with a one problem, many ways task to be solved for discussion post. So the four strategies we're going to look at are repeated subtraction, partial quotients, multiplying up, and an application of proportional reasoning. We're going to start with repeated subtraction, and I want us to remember that when children are first starting to think about what division is, one of the ways that we think about it is as repeated subtraction. That is measurement division. So this first strategy we're going to look at in the context of story problems, much as we did for repeated addition for multiplication. So the task we're going to look at is Martha has 30 ice cubes. She plans to put 5 ice cubes into each mason jar for lemonade. How many mason jars will Martha need? So we know this problem is can be modeled by 30 divided by 5. Right? How many groups of 5 are there in a group of 30? So one of the ways that children might attack this problem when they're starting to learn about division is by this idea of repeated subtraction, and to think about, if I start with 30, how many times can I subtract 5? And so they'll actually go 30 minus 5 is 25, 25 minus 5 is 20, 20 minus 5 is 15, 15 minus 5 is 10. 10 minus 5 is 5. 5 minus 5 is 0. I can't take any more 5s away, so the answer is how many times did I actually subtract 5? So 1, 2, 3, 4, 5, 6. So the answer to how many mason jars can I fill, the answer is 6 mason jars with 5 ice cubes in each. So when students begin using repeated subtraction, they start in probably the least efficient way possible, which is just subtracting the number as many times as they can. Some students quickly pick up the fact that it's a lot faster, and if you've got a large enough number that you're starting with, is that you wouldn't just take one group of 5 every time. So some students might do something like this. Or even if they don't initially, eventually they start to say, well, actually, 2 groups of 5 is 10. So 30 minus 10 is 20, and then 2 more groups of 5 is 10, and 20 minus 10 is 10, and I can get 2 more groups of 5, and 10 minus 10 is 0. So I've taken away 2 groups of 5, 2 groups of 5, and 2 groups of 5, so I've taken away 6 groups of 5, and the answer is 6. What I'd like you to do for this where I'm not going to ask you here to do a repeated subtraction task, but I am going to ask you to do one at the end in our one problem many ways. You can consider taking the divisor away one at a time, or taking it away in slightly larger groups. Second strategy we're going to look at is partial quotients. As we did with multiplication, I'm going to use string problems here to show how you can scaffold students and introduce this strategy to students, and that they can develop their own ways of using partial quotients. Partial quotients, just like partial products, is all about finding ways to make the quotient easier to divide mentally. So I'm going to start with some smaller problems and build them up to a larger problem, and we'll see how we can use these. So The first task I want you to think about is 40 divided by 4. Now, whether you think of this as a sharing problem, like 40 candy bars shared equally among 4 people, or if you think about it as repeated subtraction, and you think about it as 40 candy bars, and I'm going to make boxes of 4, how many boxes can I make? I want you to think about 40 divided by 4 just as a mental task, and I think you can probably see that that is 10. And then 24 divided by 4 is my next task. So 24 divided by 4, if I think about my multiplication facts, or I think about division as missing factor, I could say 4 times what is 24, and I can think about the answer should be 6. Now, both of these division problems should be facts that kids can do mentally. Much like doing partial products, we look for products that we can do mentally, compute mentally. So the question is, if I could do these two, how could I use these two parts to help me figure out the answer to something that I probably can't compute mentally, or I don't know mentally, 67 divided by 4. So I want you to think about what that solution should be. It turns out that 67 divided by 4, first of all, 4 is not a divisor of 67. The answer is actually 16 with a remainder of 3. And what I want us to think about is, how could I solve this knowing these? Well, if we take a look here, 40 divided by 4 we know is 10. 24 divided by 4 is 6. That means together that 64 divided by 4 is 16. Well, if 64 divided by 4 is 16, then 67 divided by 4 is 16 with 3 left over. So you can see the idea here with partial quotients is to take a dividend and a divisor and break up this dividend into other smaller dividends that you can compute mentally. So using kind of friendly numbers here. So I kind of broke this into 40 divided by 4 because I can do that mentally. 24 divided by 4, and I was looking for those two numbers that together we're going to either add up to this divisor or at least get me close. So what I'd like you to do is pause the video, and I want you to try and solve 384 divided by 6 using partial quotients. So think about numbers that add to 384 that you could use. You could break up 384 into numbers that are divisible by 6. So pause, solve, and then continue. Okay, when I look at partial quotients, I'm going to look for numbers that I know are divisible by 6 and that I can add together to get to 384. So the first thing I'm going to do is I'm going to start with 300 divided by 6, and I know that this is 50. So I've got 84 left. 6 times 12 is 72, so 72 divided by 6 is 12. So I've got 372 and there's 384. I've got 12 left. 12 divided by 6 is 2. So the answer here should be 50, 62, 64. Now there are other ways you can break this down. This happens to be the way that I did it. It might have been after 300 divided by 6, it might have been easy to do 60 divided by 6, that's a divided by, is 10. That would have got us to 360, and then we'd have 24 left divided by 6. Having troubles. And that would have gotten us 4, and we still would have gotten to 50, 64. Either one of those is fine. Any way you want to break it down. The next strategy we're going to look at is multiplying up. Now the multiplying up strategy really relies on division as missing factor, because what we're going to do is we're going to use multiplication to get us close to think about how we can solve the division problem, just like adding up is something we might use to help us solve a subtraction problem. So I'm going to give us a couple multiplication problems to think about, and then we'll see how they might be used to solve a division problem. So 3 times 100, I bet we can do mentally. That's 300. 3 times 50 is something else we should be able to do mentally. That's 150. And if I knew 3 times 100 was 300 and 3 times 50 was 150, how might I use that to think about what 453 divided by 3 was? I can start to see, so I know I've got 3's here as a factor and 3 is my divisor, so I know this is kind of where that 3 is coming from. 300 and 450, excuse me, 300 and 150 is 450, and I'm looking for 453. Oh, so one of the things I know is 3 times 150 is 450. So if this were 3 divided by 450, I know the answer is 150. But there's one more 3. How many 3's could I subtract? I could take one more out of that. So I should be able to get 100 groups of 3, 50 groups of 3, and then 1 group of 3, which should get me 151 groups of 3. So 453 divided by 3, I could find as 151 just by breaking this dividend, again, into smaller pieces and using 3 as a factor to multiply up. Notice I'm picking things like 100 and 50 and trying to get close. So multiples of hundreds, multiples of tens, those are going to be good ways to chunk this out and then be able to think about this with a larger divisor. So I'm going to give you an opportunity to try that right now. The task I'm going to ask you to do with the multiplying up strategy is 215 divided by 4. So I want you to think about 4 times what can get you close to 215, and then see if you can reason your way around what is left. Pause, solve, continue. Multiplying up, I'm going to go ahead and look for factors, things that I can multiply to get close to 200. Well, I know 4 times 50 is 200. So that's 200. I need to get to 215. 4 times 3 is 12. So right now I've got 212. And that's supposed to be 215. I don't have enough to get another 4 out of there. I have 3 left over. So the answer's got to be 53 remainder 3. So I'm using missing factor and thinking about what can I multiply to get to 215. Again, there are other ways you could do that. This is the way I happen to do it. The last strategy we're going to look at is proportional reasoning. Proportional reasoning is a strategy we're going to use, and it is similar to the doubling and halving strategy that we used in multiplication. So we're going to use the relationships between divisor and dividend, and we're going to look at how changing them proportionally could take a task that we don't know the answer to or can't solve mentally and change it to a task we are more likely to be able to solve mentally. We're basically going to find a related problem that's easier for us to solve. So I'm going to start with this division task here. 72 divided by 3. 72 divided by 3 turns out to be 24. if you try to solve 144 divided by 6, I think this is a little bit harder to do than 72 divided by 3. But in using one of our other strategies, perhaps you'll also find out that 144 divided by 6 is also 24. Well, if 72 divided by 3 is 24, 144 divided by 6 is 24, I'm going to ask you to use those two facts to help us think about what 288 divided by 12 should be. You may have reasoned that the answer is also 24, and you would be correct. Now let's take a look at how these are all related to each other. We know the answer stays the same. So if you look at the dividend, how many objects I have, when I double the number of objects, and I double the size of the group that I'm subtracting, the number in each group that I'm subtracting, or I double the number of people I'm sharing with, the quotient stays the same. So when I doubled the total and doubled the divisor, doubled the dividend, doubled the divisor, the quotient remains the same. If I double the dividend, again, and I double the divisor, again, the quotient remains the same. Well, the idea here is that if I gave you 288 divided by 12, one of the ways that you could solve this is by writing a related problem. So dividing 288 by 2 and getting 144, and taking 12 and dividing by 2 and taking half of that, 144 by 6 is going to give me, 144 divided by 6 is going to give me the same answer because it's related proportionally. But it's a little bit easier for me to solve. And if I still think these numbers are too big, I could do that again. And I could actually get to half of 144 is 72, half of 6 is 3. Now, 72 divided by 3 is a lot easier for me to think about than 288 divided by 12. But even if it wasn't, one of the things that you may notice is that, well, if I divided this by 3, this would become 1. And if I divided 72 by 3, I'd get 24 divided by 1. So you can kind of see how that would play itself out even more. It doesn't have to be 2 that I divide by. As a matter of fact, I could divide by anything I want to, as long as both the divisor and the dividend can be divided by that number without remainder. So I could actually go right from 288 divided by 12 to 72 divided by 3 by saying, oh look, 12 divided by 4 is 3, and 288 divided by 4 is 72. But the idea, again, behind proportional reasoning in division is to take a division problem where the numbers, maybe the dividend and the divisor, are both larger than what you'd like to work with, and finding a way to make it an easier version of the problem that has the same answer to solve it that way. Much like we use doubling and halving, much like we would keep the same difference when we were subtracting, right? By adding numbers to the minuend and the subtrahend, the top number and the bottom number, to make sure that they had the same answer, but they were easier to solve. So, a task for you to consider, 184 divided by 8. Think about how you could make this easier proportionally by changing the dividend and the divisor, dividend, divisor, the same way. So pause, solve, continue. You'll see a video of me solving that. You can check yourself to see how well you made sense of that strategy. Proportional reasoning, 184 divided by 8. What I'm going to try and do is turn this into a problem I can solve a little bit easier. I'm going to start by dividing both these things by 2. I know this is 92, and then this is 4. And I'm going to go ahead and do that again. This is even, so I know I can divide that by 2. And what's that going to give me? 46. divided by 2. Oh, look at that. 46 divided by 2. Well, I know that's 23. 46 divided by 2 is 23, so the answer better be 23. Again, the idea here is to change this to a problem that I can solve a little bit easier from 184 divided by 8. Okay, as promised, the last thing we're going to do here in this video is one problem many ways, and this is for whole number division. Solve the following problems using each of the strategies. Write, draw on paper, scan, upload it to Canvas. This will be discussion post 8. Again, once you've uploaded your solution, you'll see me solve each of these tasks with those strategies, and I'll try and do them in a couple ways so you can see a variety of ways to solve them. All right, this takes us to the end of mental strategies for division. Next video lecture is on division algorithms, and we'll go along with lab 7, I believe.